let's get into the big topic of open source, something that we actually say at Red Hat. We have a
This is so
we
awesome.
are an open culture that believes
It's actually
in
a big
basic
piece
What is that process that a developer, or let's say a
As the
developer-
Kubernetes ecosystem really boomed,
Hello and welcome to this week's Ask an OpenShift Administrator Office Hours live stream. As always, a mouthful, and I am co-host Andrew Sullivan, joined by my co-host, Mr. Jonny Rickard. How are you today, Jonny?
I'm good, co-host. How are you?
Yeah, it's a joint thing, right? It's shared responsibility.
That's right.
Either we both get hit by the bus, or neither one of us gets hit by the bus.
Oh man.
or we both go down with the ship. I don't know where I'm going with that.
That's right.
Let's be a little less morbid.
Yeah. BFFs.
Yeah. So, hello everyone. Welcome to the stream. This is episode 106. It's still hard to believe that we've hit that number so far, and despite a ludicrously hot week here in the eastern or central part of the U.S. for Jonny, who is letting the dog out, I think.
I gotta let the dog in.
Yeah, how's all that hot air coming in? Yeah,
it's amazing.
Yeah, because it is brutally uncomfortable here. I'm trying to avoid it, and now I'm distracted because I have another video of us up, and now I'm seeing you in double. So I gotta.
You're welcome.
I gotta close.
You're welcome.
That. I gotta move that.
Yeah, it's like 90 something Fahrenheit right now with a lot of humidity, so it's pretty miserable outside for us.
Yeah. Well, it's storming here. I'm not sure which is worse. So,
yeah.
Yeah, there's a pretty good crack of thunder a few minutes ago. But anyways, so hello to our audience. Thank you for joining us this week. Again, this is episode 106. And this week we're going to be focusing on something that we've talked about in bits and pieces, and that is hosted control planes. So this is something that is near and dear to my heart. So I'm a virtualization person, and there's lots of cool stuff that's going on there and how we can optimize and increase efficiency. But today is special and today is different because we're going to be talking about doing or using hosted control planes with bare metal servers. So I won't steal the show. I won't read the tagline, or gosh, what's the word I'm looking for? The headline right out front. Instead, I'll let our guests introduce themselves and talk about today's topic, or introduce today's topic rather. So, I don't remember who I'm handing off to. I don't remember if it's Eran
That's
or
me.
Avishay.
Avishay.
I'll take it. So, hi everyone. I'm Avishay. I'm joined with Eran. We're both senior principal software engineers in the ecosystem engineering team. And we actually joined Red Hat together a bit over 3 years ago after working together in the same startup. And
That's cool.
we, together with our team, we led the development of on-prem OpenShift deployment methods, such as the assisted installer, zero-touch provisioning, and what we'll talk about here, Hypershift on-prem. Eran also spearheaded single-node OpenShift. And lately, I've been working with strategic partners, particularly in the industrial space.
You all have quite the CV there, quite the set of credentials for going back with a lot of really cool technologies, right? Single node OpenShift is a fan favorite.
Oh yeah.
So as well as joining together, that's pretty awesome. I think we've said before, Jonny and I worked together a long time ago, and then we both, in a very circuitous way, ended up at Red Hat together. So
Right.
It's always fun to see people in the or reconnect with people, right, that you've worked with before. So that's awesome.
It's not reconnect. We never took apart.
We never disconnected.
Yeah, well, that's even better. It's even better. Congratulations on that.
You guys have matching resumes with the other side of the fist bump. You just show up together and it's
Actually, about 14 of us joined together from that company to here.
Nice.
Yeah.
So it's pretty nice.
I like how that goes. I like it when we can get lots of good people, coming from other places. So Red Hat's a great place to work. Let's see, what was the guy? I've completely derailed and lost track of mine because there's a dog staring at me through the glass down here. So anyways, so this is one of the Office Hours series of live streams here on Red Hat Live Streaming, which means that regardless or irrespective one of those isn't a word. I think it's irrespective isn't a word. Anyways, regardless of today's topic, you're welcome to ask us anything and everything that is on your mind. So for the audience, please don't hesitate to reach out through chat, through whatever it is that you're watching us on, and send in any questions. They all get aggregated up and sent over to us, and we'll do our best to address those while we're here on the stream. If we can't answer your questions, which I like to think Jonny and I are pretty smart and we generally know what we're talking about, but we don't know all of the answers, we're happy to reach back into, well, like today, into the engineering folks, or into product management, or kind of anywhere across the product in order to find those answers. So don't hesitate to reach out, and that's whether or not, or whether you're watching us live today through chat, or if you're not watching us live, you can also contact us via, usually email is the best way.
Mm-hmm.
So you can reach me at andrew.sullivan@redhat.com. If you are watching us, you can see that on the screen there. Or at Practical Andrew across all of the various social media platforms and all of those things. I will admit that I am usually terrible at actually looking at things like Twitter, because Twitter. But Slack is also a great way to reach out to us. And which one of these is the Slack one? So if you go onto the Kubernetes Slack, there is an OpenShift users channel there that Jonny and I and a whole bunch of other folks are on. That's another great way to get in touch with us. You can reach Jonny, again, via email. And he is available at Jonny, Jonny, at redhat.com, or jrocktx1 on the various social platforms. And last but not least, I'll also make a plug for OpenShift Commons. So the Commons, which is the OpenShift user community, they also have a Slack team. Yeah, they're teams, right? I don't know. I can never keep this terminology straight. Workspace, there we go. Right. So they have a Slack workspace at openshiftcommons.slack.com that anybody can join, and it's another great community of folks to participate in.
Yeah, and I think it was Our Hope 9 last week brought it up that you had to have like a Gmail or an Apple ID or something like that to join it. So I brought that up to the lead, and they were looking into it. So give it a shot. Let me know if it's still an issue, and if it is, I'll bring it back up and try and get it resolved for you.
Okay. Yeah, that must have been. I'm guessing Karina. So I wouldn't have thought that. Yeah.
Yep.
So yeah, many different ways that you can reach out to us. We try and stay on top of all those things and get back to you with questions or answers to questions and all that other stuff. So again, don't hesitate to reach out if there is anything that we can do. So let's talk about some top of mind topics, Jonny.
Yeah. So our schedule is looking awesome. We've got a lot of stuff going on. And so we've got Trilio coming out on the 2nd of August. We've got OpenShift Data Science, the Roads, coming on the 26th of next week. And then we just got confirmation that we're going to have the product manager for Scupper, or Red Hat Service Interconnect, to come on. And that's going to be at some point in August. And then Andrew and I are going to do like a split session where we go over all the things that are in 4.13, since we haven't really had an opportunity to dive into it. So we're going to dive into that, and we're going to do some more hosted control plane stuff and just kind of walk through the Hypershift CLI and just nerd out a little bit. And then finally, in September, we just got confirmation about this last night as well, is we're going to have Ortwin and one of his partners come on, and we're going to talk about Mesh Lab and Mesh in production and stuff like that. So that's another exciting topic that we got coming up. And then finally for me, okay, I said finally, I actually have two more. Last week, Istio became a graduated project in the CNCF. So congratulations to the Istio project. That's awesome. And KubeVirt 1.0, they're big time now. So they've gone from like a small project to they've got their 1.0 release. And if you're not familiar with KubeVirt, it's OpenShift virtualization for the Red Hat people. So it's awesome.
Yeah, KubeVirt is the upstream for OpenShift Virt. So yeah, it's there's a blog post for that, isn't there?
Yep, there is. I'm getting the link right now, sir.
So yeah, they there's lots of really cool stuff that's going on there, and I'm seeing more and more other organizations or other providers, vendors, adopting and integrating KubeVirt into their various offerings as well. I want to say Platform 9 offers something now. So yeah, just lots of really cool features, lots of really cool stuff happening in there. I think it was episode 96, Jonny, was when we had Ian on, or 90, it was in the late 90s. We had Ian Pilcher on, and he talked through a whole bunch of OpenShift virtualization stuff. So really interesting stuff. Lots of fun stuff that's happening there. Definitely keep an eye on it.
I haven't dug into it. That's another one that we should do, just where me and you just nerd out on OpenShift virtualization, because I haven't really messed with it a whole lot. So it'd be kind of fun to dig into it.
I have messed with it a whole lot.
Oh yeah,
so
I'm sure.
Yeah.
After you play with Hypershift and you play with OpenShift virtualization, you can actually do both together.
Yeah.
That's awesome.
Workers with Kubevert.
Yeah, that's something that we've been. I've been talking with the product management team about in the background. Of we should definitely, whenever their Kubevert or the Kubevert provider for hosted control planes becomes available, which I think it's tech preview now, we should definitely have them on the stream. Because it's OpenShift hosting OpenShift, and it's in an integrated manner, so it's really cool stuff.
That's awesome.
Yeah, Martin, it is a lot of fun. I was actually talking with Eric Hendricks. Eric reached out to me. So he's the host of the RHEL live stream over on the Red Hat Enterprise Linux YouTube channel. And he was asking me questions. He's like, hey, I replaced my entire home lab with OpenShift virtualization. I'm like, all right, let's go. So he was asking me questions about, Kubernetes stuff and, how to learn as a RHEL admin, how to learn about Kubernetes and OpenShift and what all this stuff means and how to deploy VMs and stuff like that. So yeah, lots of cool stuff in there. Dwayne, I'm not sure.
I'm going to find it right now.
Yeah. So there's a short link that you can use to go and see all of the it goes directly to the playlist for Ask an OpenShift Admin, and it's red.ht/AOA. Let's see. So 99 was VMware. Has it been that long since we had Ian on? Man. Yeah, episode 89. Wow. Time flies when you're having fun and getting old. So there you go. Episode 89 was when we talked about OpenShift virtualization. So I had two things on the list here. So one, so an account team reached out to me, and then I ended up communicating with one of our customers over some confusion about how or when a cluster is provisioned using assisted installer, and when you provision that cluster, when you select cluster managed networking. So let me see if I can bring this up. Let's see. I want to share my window. It's the giant red one. So if I go to console.redhat.com/OpenShift and wait for it to load, come on, internet. So I'll create a cluster. I'm going to create the cluster using assisted installer. So we'll just call this one AOA.com because I don't need it to actually be valid. So if I select this DHCP only, and then I go to next, and next. So I don't think I'll actually be able to get to it's on the networking option. So without joining hosts, I won't be able to show it. But on the networking tab, there's an option for either cluster managed networking or user managed networking. So if you select user managed networking, it's effectively exactly like you would expect with any OpenShift cluster, right? You're responsible for provisioning the load balancer, for managing the DNS entries for start.apps and API and all that other stuff. If you do cluster-based networking or cluster managed networking, even though it's a UPI install or a non-integrated install, not an IPI install, it will use the integrated keep alive D virtual IP addresses for those quote unquote load balancer endpoints. So start.apps and API. So the problem or the quirk that happens is when you do that, the nodes, and again, it doesn't matter if they're actually physical, if they're virtual machines, it doesn't matter where they come from or where they're hosted, the nodes, when they join the cluster, show up as bare metal nodes. And it's a quirk of how, because it's using Keep Alive D and it's using those VIPs, that it just assumes it's like a fall through thing where it assumes that they're bare metal nodes that are, part of a platform bare metal type of cluster. So even though it's platform non-integrated, they show up as bare metal. So this is important. Go ahead.
I want to maybe add to that. So you can actually, so whenever you say, I want to get user provision networking, you're essentially saying, I want to get non-platform. And if you're choosing the cluster managed networking, then it's going to be somewhere in between, as you said, bare metal. And now, like we are going to use the Keep Alive D, and we're going to create VIPs. And if we notice that it's running on, let's say, OpenStack, we'll say, okay, you can't really do that. But if we see that, okay, it's libvirt or something that we know that should work, then we'll allow it. And if we actually notice that it's vSphere, then we'll offer you, okay, you can do the vSphere integration. You don't have to use bare metal.
Yeah. Yeah, there's a toggle. I think it shows up on the next, either on this one or the next page. Yeah. Integrate with virtualization platform. I thought that one was to deploy the OpenShift virtualization operator, which is actually on the previous screen.
Right. So now we can integrate with vSphere, Nutanix, and we just added Oracle.
Oh, that's cool.
But yeah, as Eran said, kind of, if you choose cluster managed, it's the bare metal platform, and that's why you're seeing bare metal artifacts there.
Yeah, it's slightly confusing, but harmless.
Yep.
So yeah. Anyway, I was talking with a customer, and they had wanted to add. They deployed their cluster using assisted installer to using virtual machines and that UPI cluster managed networking scenario. So they showed up as bare metal, and then they had wanted to use the bare metal IPI experience to add physical nodes into the cluster. And it just, because it's a platform non-cluster, even though the nodes are showing up as bare metal, virtual nodes are showing up as bare metal, it just doesn't work like that. So slightly confusing, slightly, not perfect, but
maybe something to add to that. So you can actually add the day-2 worker nodes and make master is a bit more complicated, but you can do it from SaaS. The only gap is that you'll need to approve the node CSR, the certificate sign request, yourself.
You just can't use the Metal Cubed or Metal 3 integration to automatically, like with machine sets, provision and integrate those nodes. You can absolutely do the standard, IPI method of manually adding nodes, or use the assisted installer interface to provision those nodes, join those nodes. Both of those work exactly as expected. What was the other thing? Oh, the other thing, real quick. So somebody had asked on the internal answers platform about the size of the etcd database. So the etcd database is, I think they test up to something like 8 gigabytes total size for the database, and I think it's up to 1 megabyte. And I don't know if that's an etcd limitation or just what we test, but up to 1 megabyte per record size. So this is important for a couple of reasons, mostly because people want to plan around capacity and stuff like that. So a lot of times we will pay attention to, especially when we're provisioning clusters, we'll pay attention to the disks that the control plane nodes are using. Generally speaking, etcd isn't a huge concern when it comes to the capacity. It's the latency that we want to pay attention to. I always reinforce with folks, I always tell folks, etcd latency is by far the most important metric when it comes to etcd. Secondary by a long shot is IOPS, because again, the largest record size is going to be a single megabyte. So it's usually only a few IOPS to do each one of the operations, but it needs to be low latency, both at the disk level as well as at the network level. And we've talked about that in depth in other episodes, including, I think, when we had the etcd folks on back in, I don't even remember what episode that was, Jonny. I don't know if, let's see, I could probably find it here real quick. That was episode 21. Wow, that was a long time ago. We should probably revisit that topic since it's been that long. 21 would have been back almost 2 years ago.
Yeah, before my time.
Yeah, you came on in the 40s. So
that's right.
Old timer now.
I know. Seasoned vet.
All right, that's all I got. I got nothing else. So aside from, I forgot to mute all my notifications, so I'm listening to a bunch of dings and bings and clicks and clacks and stuff happening in the background. So now I got to do that. So you want to kick off today's topic?
Yeah. All right. Eran, Avishay, let's get after it. This is an awesome subject, right? Like we've been excited about this. Like I'm a huge fan of Hypershift. I really started kicking the tires with it a couple weeks ago, and yeah, I'm like super impressed with it. There's one thing, I have one grumpy thing, but I'll take that offline. But other than that, like it's an awesome project, and like I'm super excited about where it's gonna go. And I love this topic today. Get after it.
Okay. Eran, you're muted.
Yep.
I got it. It was
Wasn't
muted.
me.
Muted in the platform. I unmuted you.
Okay, cool. I wanted to say that we're responsible mainly for the integration with Hypershift, or between Hypershift and the system installer. But Avishay, go ahead.
Yes, I'll just give a quick introduction to hosted control planes for whoever's not familiar. You might have also heard of it called Hypershift. That's the upstream name. So let's say we have a standard OpenShift cluster. We call it the management cluster. And then we want to add additional clusters in our environment. So what hosted control planes does is actually runs the control planes for those additional clusters as pods, as workloads on this existing management cluster. And so why would you do that? So first of all, bringing up pods is much quicker than bringing up actual machines. So you could get your control plane up in, let's say, 10 minutes instead of 30, 40 minutes. It's more cost effective. So instead, especially with bare metal, so with standard OpenShift, standalone OpenShift, you're using 3 dedicated machines for each control plane. And here you're kind of packing them together. And there's a whole lot of other benefits that you probably heard about in the hosted control planes episode with ease of management, multi-tenancy, and so on. Not going to really go into that. But each of these control planes is running in its own namespace on the management cluster. We'll see that in action in the demo in a minute. Then we have a resource called a node pool, which is managing the worker nodes. And those worker nodes are external to the management cluster. They can even be on a different network than the management cluster. This thing is called a hosted cluster, the hosted control plane plus the workers. And that's basically hosted control planes in 30 seconds.
Yeah, and I want to point out and kind of reinforce a couple of things here of, so the hosting cluster, or the managed cluster, I think is what you all
Management
call it.
cluster.
Management
Yeah.
cluster. So it can be physical or virtual. It doesn't matter whether, and it can manage or host control planes for physical or virtual clusters, right? It doesn't matter.
Right.
And those control plane services are deployed as pods into a namespace in that cluster. So I think this is important for a couple of reasons. One, it means that it's really fast to deploy those new control planes. Right? We're not having to wait for a virtual machine or a physical server to get deployed. Not having to wait for CoreOS to be deployed and configured and everything to stand up and find each other and do all of those things. Right? It just deploys some pods and is pretty quick to stand things up. I think the last time I used it, we did a whole cluster provisioning, and I don't know, you guys probably know far better than I do what the provisioning times are, but it's like way less than 10 minutes most of the time. So it's deployed as pods, which is really cool for a couple of reasons. In my opinion, one, it means that we can decouple control plane scaling from the node sizes. So as that hosted cluster, as it's putting more demand on the control plane, it's consuming resources in the management cluster. I don't have to go through this rigmarole of, I need to remove a control plane node and then resize it, or deploy a new one that's of the new size and then rejoin it and go through the whole process. Rather, it's just, at worst, I'm having to add a new or a larger node onto the management cluster. So particularly if you have a lot of cluster churn, right, that can be kind of a big deal.
Mm-hmm.
That's right. Your control planes are now Kubernetes workloads, so you can scale them up, scale them down.
Yeah.
It also decouples the platform. You can run the control plane on x86, and you can add workers to it, running on ARM machine, on DPUs.
Yeah, I don't know whether or not it's supported, but I remember when I was using OpenShift or hosting control planes, this has been like 6 months ago, I had my management cluster deployed in like US East, and then I had other clusters deployed in US West, like multiple regions in US West, and they were deploying managed clusters from there. And like it was this whole tiering out thing. And I don't know if AWS is a target platform. I know it's used by ROSA.
Yeah.
But
so right now, hosted control planes is tech preview. It's shipped as part of multi-cluster engine and ACM. It's aiming to be GA in the next version. And it's available as tech preview on AWS self-managed, so running it yourself, or as part of ROSA, as you just mentioned, tech preview as well. IBM Cloud is also using it for their managed service. And you can also use bare metal, which is what we'll show, and KubeVirt. So those are the kind of plugins that are available.
Very cool. Thank you.
Okay, want to get started?
Yes, please.
Okay, cool. Let me share my screen and. Okay, cool. So here you can see the management cluster. Okay, simple OpenShift as you know it. I installed multi-cluster engine on it, and that gives you this cute button that allows you to go to this amazing console. And here we can see the multi-cluster engine UI. And so first thing I want to do is I want to create a host inventory. Okay, so for that, I'm going to create an infrastructure environment. This is where we're going to say how our infrastructure look like. I'm going to call out my guest, my agents, and I'm going to describe where it is. I'm going to say, okay, it's local. We can add labels to it. If we add a label here, it will be added to all the hosts that are booted with this infrastructure environment. The point of infrastructure environment is essentially to create a bootable ISO for us to boot the host with. I'm gonna need my pull secret for a second. So Sully, can you please? Thank you.
Yeah, we don't want to have another one of those incidents.
That's right, because it is not easy. Get a new one.
I think both Jonny and I have accidentally exposed our pull secrets before, so.
So for whoever's in, so if you guys know assisted installer, so it's that same. We're now creating that same ISO that you would create over there, and we call that the infrastructure environment.
Okay.
So here I added my SSH key just in case I'm going to have to SSH into the node and understand what's going on. So here we got the infrastructure environment, and within a minute this should go away. Now I'd like to add a host to it. So there are a few options. You can either download the ISO. Okay. Let's give it a sec.
And so if I remember correctly, and I admit that it's been a minute since I used the infrastructure environments inside of ACM, you can create that ISO and boot the nodes to it, and they just kind of go into a waiting pool to be assigned out to clusters.
Exactly.
So I think that's really cool and I see all the different methods for booting there. I think that's really cool for a number of different reasons. I remember I was a VMware administrator for a long time, and we would go in when we were doing provisioning and basically boot every one of the servers and just let them pixie boot off of the network and boot into, ESXi, boot and install into ESXi. And this is kind of a very similar capability, right? I can boot my hosts however I choose to. They all go in and they register into the interface. And then as the administrator, I can go in and create clusters however I want, right? I want this node, nodes 1, 3, and 5 to go in and be control plane nodes for cluster A. I want nodes 2 and 4 to be worker nodes for cluster Z, all this other stuff. So
Yeah.
I really like that experience.
Cool.
So this
just
is
gonna show-
actually the assisted installer that's running on console.redhat.com. It's actually running here as part of multi-cluster engine as an operator. So it's 99% the same code. The workflow is a little different because in console.redhat.com, we have a simplified flow where you create a cluster, you add hosts to that cluster specifically. And here we give a more long-term view where you can create a pool of hosts and kind of attach them to different clusters. These hosts that are going to come up, we call them agents here. You can attribute them, or we call it binding. You can bind them to a regular OpenShift cluster or to a hosted cluster.
Right. So here I just show you how you can create one with the BMC credentials. You can also just apply YAMLs. So here I have I have the management cluster kubeconfig, and I have this which has all the BMH YAMLs, and I'm going to apply that.
The bare metal host is part of the bare metal operator using metal cubed and ironic to boot these hosts.
Okay, awesome.
Okay, and as I create them, this is fun. Okay. Guess it needs to copy them.
And we have some really deep integration with metal cubed and ironic. So it's actually booting the ISO automatically.
And Ironic is the project that that's what OpenStack uses that for their provisioning as well, right?
Correct.
Okay.
Yeah, and I was just going to ask so my understanding of Metal 3, I think it's Metal Cubed, is it effectively uses the same mechanisms as Ironic. So you give it information to connect to the BMC, or I think it'll use Redfish or a couple of other different methods, IPMI. And it just programmatically through the API interacts with and configures that host. So things like you said, it attaches the ISO and it boots the node, the physical node, to that so that it can register and join. Or with IPI, we're doing things like installing CoreOS and configuring other aspects of that node in order to join. Let's see, what is it? Is it the, what do we call the poison pill operator now? Self-node remediation, node self-remediation operator, I think.
Yep.
Where it'll use that same thing to, it'll talk to the node via Metal Cube, via the BMC, and forcefully reboot the node, so that way we can authoritatively determine that it has been disconnected, there's no PVCs connected, and restart workload. So really cool stuff.
So as you said, it's using Redfish, and currently what it's doing, Ironic booted the machines, it's running its agent on it, and it's inspecting the hardware. This is actually new to 4.13. So far, it was booting the machines with an ISO we generate, and it was booting, and it was running the assisted service agent, assisted installer agent, and that was the code that was inspecting and doing all the inventory, collecting all the inventory from the host. And right now we have a new thing. It's called we call it the converge flow, where both Ironic agent and the assisted agent can run on the same host. They do some handoff between them. Ironic is doing the inspection, and later on it runs the assisted installer or the agent to perform the actual installation. This actually enables a new cool feature like the Pixie option we saw earlier. It'll also enable the customers to do firmware setting, BIOS upgrade, all that. We can now support that. So currently it's still in spec.
I didn't know that. So I'm going to tangent for a moment. How can you configure that type of stuff? Is that done through machine config?
No. So if you not in this flow, the way you do it is when you apply the bare metal host YAML, you can add you need to add how's it called, firmware settings. I don't remember something firmware settings.
Okay.
Give me a minute.
We don't have to dig into it. I would just that's really cool. I did not know that we could do that, and that's exciting to me.
Yeah, it's just one more CRD that is available to you, and you can choose to configure or upgrade the firmware with that. So right now it's provisioning, and soon enough it should be available for us. We can go ahead and start create the cluster, and we'll see them as available once we'll need them. Oh, okay.
So Eran, quick question. Are we able to do this in like disconnected environments as well? Like, is yes. All of this supported completely disconnected?
Yep.
Okay, so yes, Hypershift. There are some gaps. Like what we see here works in disconnected. There are some gaps in Hypershift, but people are nailing it down these days. Like this should get resolved.
Okay, awesome. I got asked about it last night. That's why I brought it up. So
here you can see in the UI, it should remind you a bit of what the assisted installer looks like in the SaaS.
Mm-hmm.
You see the agents coming up in the inventory.
And you notice that the host name got updated because after they did the inspection and the hardware information and checked all the hardware, it noticed, okay, it got a different host name than what we thought it's going to be, and it just updated here. You can actually change it if you like, and it will set that on the host. And now we see that those hosts are available to us. They pass the hardware checks, the networking checks, and we can go ahead and create a hosted cluster. So here we see the local cluster, the one we're running on, the management one. And if I click here, I got multiple options. So we can create one on AWS, GCP. We can use Red virtualization that you mentioned, but we are going to use the host inventory. And I think this is something that will look very similar to if I choose standalone and I want to use existing host. This is very close to the same UI you showed earlier of the assisted, but we're not going to do that. We will use, hosted control plane. Okay, so let's create a cluster. It's going to be my cluster. I'll choose to use the default cluster set. This essentially determines what OS we're going to put the host with. Here I'm going to use redhat.com. We're going to install 4.13.4. Again, can I ask you to please hide my screen?
So while you're doing the copy pasta, the 4.13, is that based off of the hosted cluster's environment that it can deploy, or like you know what I mean? Like, is it kind of like the Cincinnati operator where you've got like the graph where you can kind of go through like a stable channel, or is it like basically like you have to do hosted cluster level and greater? What's the, it says OCP version there. Like I imagine that's a selectable field. So like what are the fields that I can select?
So assisted service gets its own configuration for what OpenShift we support, or what images, what release images it knows in this let's say self-hosted environment.
Can we reshare?
So it's yeah, sure. Yeah, I just click next from the previous screen. I added my pool secret and I click next. And so there are a few constructs to hosted control plane. There's the hosted control plane and there's the node pool. And both of them together compose the hosted cluster. So earlier I created the hosted control plane, and now we're looking at the node pool. Here we can choose the namespace that we're going to consume the agent from. We have only one, so we're going to use that one. We can filter which agent we want by label. Like if we choose this one, we're going to only get the agents that have this specific label, and there's only going to be one. We can filter them by location. All those labels are automatically added. I think this is something Avishay did a while back. By the host inventory. Once we see the inventory, we just add labels that reflect what this host looks like to us, and then later users can use it to filter the host. But I'm not going to do that. We have 4 available ones. Yeah, go.
So you can either use the pre-generated labels that we have on agents, you can add them manually yourself, or you can even create rules based on the host's inventory as to what labels will be applied. So you could say, like, if it has, between this much and this much CPU and RAM, then it's a medium label, right? And then you can, in your node pool, say, I want workers that are medium. Or you can say, I want workers that are in this availability zone. So this filtering option is really useful for, you can even have multiple node pools for the same hosted cluster.
Yeah.
So you can say, I want some that are medium and I want some that are large, or I want some in this region, some in that region.
Okay, and that's really how you set up the multi-tenancy aspect of it, like where somebody wants to come in and say, like, hey, I just need a node really quick over in with a, this type of CPU or this type of RAM or whatever, or this much RAM, and then they can just select that node pool and then go. Is that kind of the idea?
In terms of multi-tenancy,
I'm thinking like you've got this cluster, right? You've got a team, right? And like hey, I just need to spin up a cluster really quick to do something. That's my idea of like multi-tenancy. Yeah, just more of like the self-service.
Yeah, so you could just spin up a hosted cluster for them with that one worker.
Okay, gotcha.
And get it in a few minutes.
I think this is what we'll do now. We'll spin a hosted cluster for them with just one worker. Okay, here we got the networking part of this. And so I'm going to use node port to expose this, the hosted cluster API service. We can configure advanced networking options, but we can also skip that. I'll add my SSH key again. This is in case we want to be able to SSH to the nodes of the resulting cluster, the worker nodes. When I click next, we can, if you want, create some automation that multi-cluster engine will apply on your resulted cluster, and you can create an automation and refer to it here, and it will deploy you different operators you want, whatever you configure in your own automation. And here we can review everything, and if we're happy with it, we can go ahead and click create. And cool. Okay, so now the hosted control plane operator is going to create our hosted control plane. So don't be scared, as all of these will turn on green soon enough. But you can see all the status condition of the hosted control plane reflected here. And essentially at this point, we can actually we can see that the node pool is still pending host assignment. This is because it doesn't have an available ignition endpoint. But what we can do now, while this is, let's call it bootstrapping, we can go and look at the control plane pods. So if I click here, I go back to the management cluster, regular OpenShift console UI. Hopefully this will load faster. Okay, yeah.
It's taking its time. It's okay. So far, we haven't had a Jonny level event happen inside of the environment. So
yeah, everything's working.
So far. Okay, so Avishay, you want to walk us through on what's running, what it's doing? Because I think my voice is fine.
So here we're looking at the namespace that's hosting those pods that make up the hosted control plane. We can see the first two pods are for CAPI or Cluster API. So that's a Kubernetes subproject that's dealing with cluster lifecycle, and hosted control planes uses that in the background, kind of internally, to manage the worker nodes. So Eran and I created a cluster API provider that links Hypershift to the assisted installer. And the cluster API providers are also used for the AWS integration and KubeVirt integration and others. So that's really cool, like utilizing this open source upstream for kind of dealing with our workers and managing them, bringing them up, taking them down, auto scaling.
And
exactly. If you would start hosted control plane with AWS, this CAPI provider will be AWS CAPI provider. CAPI provider AWS.
You all probably know this better than I do, but if I remember correctly, wasn't Machine API more or less a fork of Cluster API?
Correct.
Okay.
And I think OpenShift wants to, at some point, transition back to Cluster API.
I mean, we kind of are, right? I mean, you've got Cluster API here for hosted control planes, so kind of getting the best of both worlds here.
Yeah. Other control plane parts that run here is etcd that we seen earlier, the Kube scheduler, the Kube API server. It's all running here. The controller manager. So essentially the control plane plus, let's say, connectivity server, which is the proxy that allows the control plane to talk with the worker nodes, and everything gets resolved as if they're on the same network.
Another thing we can see is that here we have, for example, one copy of etcd, but you also have the option of running it highly available with 3 copies, and you would have anti-affinity between them to run on different nodes. So you have that flexibility.
And that's defined through the CR, the custom resource that's created?
Yes.
Yes. You can ask for an HA, highly available hosted control plane, and you'll just get 3 replicas, 2 replicas from whatever you need. Okay, let's go back to MC, and now we can see that the node pool is not ready. Oh, it's already okay. I thought this would take longer. Okay.
We talked for too long. It's already done.
Yeah. Okay, it's installed. I'm kidding. So essentially, once it has an available ignition endpoint, the CAPI provider CAPI cluster API will generate machine deployment and a machine, and then the CAPI provider will try to reconcile that machine to make that machine happy by binding an agent machine. So all of these are different CRDs that are trying to make Cluster API happy by essentially making one of our available agents to join this cluster. And once all these are linked together and the agent machine finds an available agent, then it binds it to the cluster. And once it's bound to a cluster, the assisted installer will start installing this node. Actually, it will first perform few validations, like it will make sure it can reach the ignition endpoint. It will make sure it can actually download the few images of this release, just to make sure that the pull secret that we added is valid for this kind of installation. It also performs some checks about like the disk speeds and other networking checks. And once all that passes and we're happy, then it's gonna kickstart the installation. It will write Arcus image to disk with what we call a pointer ignition that will point to the ignition endpoint. And then I'm gonna tell Ironic, okay, I'm done. You can go ahead and reboot. And at this point, Ironic will reboot. I think soon enough. We can go back to our host inventory and see it here that we have 4 hosts and one of them is bound to this cluster and it's installing while the other are available. But if we don't actually need to wait for the host to join, we can already talk to this cluster. So let me download the kubeconfig, and because the API is up, everything is already running, we can actually talk to it, and the worker will join once it's rebooting. So here I'm just going to edit the Sage kubeconfig with this new kubeconfig. I just downloaded. So on the lower screen, I'm just going to use the CCAP. So this is talking to the hosted control plane, and you can see that it has like one pod running, but there are no nodes yet, which is kind of cool. What else can we ask it? So we've got a bunch of namespaces. So we're talking to the API, and we're still waiting for our node to start.
So one of the things I wanted to ask about, and I don't know, I seem to recall that in the now I'm not gonna remember the name of the CRD for provisioning the cluster. Not node pool. Is it managed cluster?
So it's actually
Hosted
the
cluster.
CRD is called hosted cluster or hosted control plane.
Okay. Managed cluster is the ACM object, I think. So I seem to recall that in that CRD for the hosted cluster, you can configure some properties of the deployed cluster as well. So things like authentication and some other basic properties, which to me, one, I think it's interesting that you can completely programmatically, it's just the Kubernetes API, deploy and manage clusters as sort of that cluster administrator or super administrator type of role. Two, and Jonny will like this, you can also do it all entirely GitOps based, right? So you can use a GitOps paradigm in order to go in and not only spin up a new cluster, the hosted control plane aspect, the node pool aspect, the nodes that are joining, the configuration of those nodes, all from a single cluster. And then if you're using ACM as well, because from what I recall, MCE, multi-cluster engine, doesn't require ACM, but ACM requires MCE, I think. So yeah, if you're tying in with ACM, then you can use ACM to further, configure and manage those clusters in all of the different ways. So we start to see this holistic view of doing end-to-end cluster management, lifecycle management through all of these different tools. And again, all programmatically, so you can adapt it and adopt it into whatever systems processes you're already using. I did have a question for you though. What is how does node auto scaling work with a hosted cluster?
Cool. So I'm going to show that in, I don't know, I guess 4 minutes. We'll get there.
Okay. Alan asked a question. Can you deploy with bonded NICs using mode 4 or LACP?
So I think you can. So first, when I created the infrastructure environment, you can always add static network configuration to that, and it will configure the NICs however you like. Other than that, once it has static network configuration, usually, I'm pretty sure of that, the system installer will, when it installs the core OS, it also add the -- copy network option. So that should preserve the same networking configuration you added there throughout, like after the node is booted with the ignition endpoint. So it should stay the same. Haven't tried what exactly you asked, but this is.
I think the short answer is if it doesn't work, open a bug.
Yeah.
Yeah.
It should work.
Yeah, and if you don't need that for the first or the primary network, right, the one that has an IP address on the machine network.cider in install config, you can always do it day 2 as well, using nm state or something.
Yeah. Wait, so you see, we have one node. It's ready. It's happy. Now, one thing I'm gonna do now is I'm gonna configure the load balancer for the ingress traffic. Okay, so sadly, as of now, currently we do not have like a platform integrated load balancer. So we need to do it some other way. So what I'm doing is I'm going to deploy MetaLB on this on the hosted cluster. Okay, and I'm going to use a subscription and I'm going to deploy it. Then I'm going to create one. I'll create an IP address pool. It will just have this one single IP. And then I'm going to create an L2 advertisement that will tell everyone, okay, this is the IP that we're using. If you have hosts on different layer 2 network, then you should use BGP advertisement or something else. But that's also supported. You don't have to have all worker nodes on the same subnet. You can bring them with different places. And then at the end, I'm going to expose the ingress via this load balancer type service. So I'm just going to start that. And if you have any questions, go ahead.
I do have questions. And for anyone in the audience, don't hesitate to ask questions too. So that was one of the questions that had popped into my head before is hosted control planes. We're deploying all of the control plane services into an existing cluster, which I can only assume means that we're using a route to expose access to the API endpoint, which now that I think about it has its own set of questions because routes normally are only port 80 and 443 and the API is normally 6443. Anyways, we can get to that later. So for the cluster, the hosted cluster, the managed cluster, hosted cluster, where does its start out apps and all of that, where does that get hosted at? Is that deployed in the normal way using the ingress controller? And then I think maybe that's what you're doing now is deploying Metal LB to then expose those ingress controllers so that you can point start out apps at that.
Exactly.
Okay.
That's exactly what I'm doing. So it took a bit longer than I thought. So I'm just gonna rerun it so the Metal LB will get deployed, apply the CRD, and we can create one. And about with the other questions, so you can see it here. So if I'll do that's config. So you can see this is how we get to the hosted cluster API right now. So I use node port, so that's why it's actually using the node port to get into that. If we were having MetaLB on the management cluster or some other, load balancer running on the management cluster, then we could use a load balancer.
Okay. And I would say, that might require some additional config, but I assume not because, if you're interacting with an OC, it's probably using the kubeconfig file to interact with it, and it has all of that port information and everything in it. So I don't know. For some reason, there's something sticking out in my head of like it was for a while, or I don't know. It didn't want to change the API from 6443, or we didn't support changing the API port from 6443. So that's really cool to see that being more flexible.
Okay, so after we configure the load balancer, we should be able to get to the hosted cluster console. Cool. Okay. Let's see that we can get there. Let me just go grab the credentials.
And the cool thing too is when you have the hosted cluster, if you were to do like an OC get nodes, you only see your workload, right? You don't see the control plane nodes and stuff like that. So it's got a very similar feel to like EKS and AKS, right? Like where you get your cluster, you go and do your thing, and like as far as you're just in your bubble doing your work, right?
So Alan, this is what we're showing. This is on-prem ACM, and it's the tech preview. But yeah, so cool. Here we can see.
If you check the docs, there is a step to enable hosted control planes.
Yeah.
Yeah.
And another step to enable we call it central infrastructure management. That's kind of the code name for assisted installer on-prem. So you'll have to enable those, but once you do that, then you'll be able to see everything just like this.
Okay, so as you can see, this is, I guess, somewhat special. Like it's an OpenShift cluster. It's a hosted control plane OpenShift cluster, but it just have one worker and nothing else. So pretty cool. And I think now we can get to the question you asked earlier about, okay, how does auto-scaling work? So I want to say it works real nice. So let's create a deployment. Okay. Just make sure this is the hosted control plane. Yeah, cool. Okay, and just to make the autoscaler work, I'm gonna define some minimum requirement for my deployment. Okay, if we go to the console, we should be able to see, okay, deployments. And here it is. So I asked for like 5 gigs for each pod in this deployment. So let's just scale it up to 5 and see what it's doing. Okay, cool. So it's running workloads, which is nice, but not all of them, because some pods can start because I do not have sufficient memory. Okay, so here's the cool part. We do not have a UI for this yet, but so this is the configuration we want to do on the management cluster. So I'm gonna get the node pool, and I'm gonna patch it if this. Okay, I need to patch. This is namespace, this is the name. And the patch goes like this. It's going to remove the replicas. And instead, because currently it has replica 1, and I'm going to replace it with autoscaling. And I'm going to say, okay, we want minimum of 1 host. And if you need more, then you can take up to 4. And the minute we do that, if we go here, we see, okay, it's immediately the autoscaler created a machine, the CABI provider created the agent machine, it found an available agent, it's binding it to the cluster, and soon enough it will start the installation, all the part that we missed earlier, the validations that it's running, and once it's happy with the host, then it's going to start the installation. So that's how autoscaling works, and once the node joins, we can see that, okay, all pods are running. We can scale the application down again, and a few minutes after, the autoscaler will say, okay, I don't really need 2 hosts here. So it will scale it back down again. And this host should go back, and as we'll see it soon enough, should go back, or one of the hosts will go back and become available here. So now you can see it's insufficient, and it's bound to this cluster. And if we look, okay, so it's saying, I can't reach the ignition endpoint yet. So these are validations that are still in flight. And so it knows that it's bound to a cluster. It needs to pass all these validations. They did not pass yet, so we're getting this warning. But
right, it says they're pending input, so it's waiting to get more information.
yeah, so right now, the agent that's running on the host is running those validations, making sure that that if we kickstart the installation of this host, adding it to the hosted control plane, that this should succeed. This is how, I guess, this is the magic behind assisted installer and how it gets such great installation success rate. Because before you start anything, we try to make sure that this should work.
Yeah, I think we talked about that with Rom when he was on to talk about assisted installer and how, you know, if you choose the node to be a control plane node, it does things like run a disk latency test to check and see if the disks are adequate for etcd. You know, a whole bunch of other validations that, you know, we were just looking at. I always thought that was really cool, and I really like that it does that.
All right, and now you can see it's starting the installation, and soon enough we'll see, okay, it's gonna write to disk, it's gonna reboot, and sometime later the host should show up here. This is the host control plane still waiting to get more compute. there anything else we want to show you guys? Any questions, maybe?
What's next? I'm sorry. Yeah.
no, I'm just watching. It's funny because I remember when we first started exploring this and looking at it, way back. Gosh, now it is completely escaping my mind. So anyway, the ACM team also has a live stream, and their very first stream, which was the better part of a year ago, was on hosted control planes. And it's so much fun to me to see the maturation and everything that's happened since then, and just this overall experience. Again, I think in perspective of if I'm a super administrator, right? I'm the administrator of all of these open shifts. This is hugely powerful, and not just because it increases efficiency, but because of the manageability aspects. The centralized control aspects, even more so than using something like ACM or GitOps or any of the other tools.
I want to say this is like we're showing it from the UI because it's super cool showing it from the UI, but you can do everything with YAMLs. You can do everything with CLI. This is really something that is comfortable to work with.
And for a SRE that has to manage a bunch of clusters, just having them all, as workloads on a single cluster, not having to, find where each one is and debug them separately. You're basically debugging OpenShift workloads. So it's much easier. And for Metal, we really created this bare metal cloud. You have a pool of hosts and you could just take them, auto scale them as necessary. When you're done with them, you just return them to the pool.
Yeah.
I do want to say maybe because Alan just asked what's happening at 5 out of the 9. So currently it's waiting for Ironic to boot the node, but I want to say this is something like this, some delay that was just added because as I mentioned earlier, we had this converge flow happening in 4.13, and apparently it added like a minute here, 2 minutes there to do this handoff that the assistant agent and Ironic agent won't step on each other's toes, and maybe there's some optimization we can make there to make this happen faster.
So I'll So I guess a couple of things. So one, I know we're coming up on an hour and 15 minutes, and I know for you all, it's late in the day. I see the sun setting over there. So we don't want to keep you on too much longer. So for the audience, if you have any questions, comments, thoughts, please don't hesitate to post those into chat. Or as always, if you're not watching us live, reach out to Jonny and I, andrew.sullivan@redhat.com or johnny@redhat.com. And then I want to get back to Jonny. You started asking a question there, which was, what's next? What's the future of hosted control planes look like?
Yeah, exactly. Without going into too much roadmap stuff, right? Like, because I don't want to put you in a predicament. But
I mean, clearly GA, right? But
yeah. But like, what's some of the next hotness with hosted control planes, and especially like the assisted installer, because this is awesome, right? Like Avishay, I think you said it really well, right? You have the single pane of glass for SREs, and that really loops into the governance aspect of it, right? So it's like when you start talking about like application governance and cluster governance and stuff like that, and really understanding your environment, it's hard to beat this. This is really awesome.
Yeah, it makes managing much easier. You can even, we didn't mention this, but you can even upgrade the worker nodes separately from the control plane. So if you have like a maintenance window, but you need to patch a critical CV on the control plane, so you can do that. In terms of what's next, a lot of effort went into Rosa lately, and the focus now, as you said, is GA. In terms of more roadmap, Eran, do you know? I don't want to speak for product management.
No, I think mainly the focus is going GA.
Nice. Well, this is awesome. I think that like I can see a lot of use cases for this. I had somebody hit me up last night literally about the same topic about bare metal and assisted installer. So like, it's definitely, it's kind of funny how we've gone from like this big cloud conversation. Now we're back to on-prem with bare metal again. So I think it's really good.
Okay, so it took a few minutes, and now we have the second worker here, and hopefully all pods are running. Let's see, we got 5 out of 5. So that's nice. And if we scale it down and wait it long enough, which I think is about 10 minutes, it will come back. But since I don't really want to wait that long, we can just edit the node pool, and so we can set it back to use, instead of auto scaling, we want to do replicas again. And I'm going to say 1. And
The autoscaler takes some time to kick in. It doesn't want to take away the nodes too quickly, right?
Mm-hmm.
Yep. So as you can see, the node just went away. If we go to compute, it's going away. I want to hope.
Cluster API is doing the cleanup and properly removing that node.
And if we look at host inventory, we should see that, okay, it's removing from the cluster, and soon enough, this should reboot back to the ISO that we were booting it with and become available again to be used by other clusters.
I love that. I love that it's just this continuous pool of hosts that you can use and reuse over and over and over again. And
Me too.
I've talked with several partners lately, mostly storage partners, who they go in and when they're doing a CI run for their CSI plugin, they'll need to deploy a bunch of different clusters with a bunch of different versions and just constantly cycle through those. I feel like this is going to be a huge benefit to doing something like that. Hey, I need to test with OpenShift 4.12 and 4.13 and even different Z streams. I don't know. That's a question kind of unrelated to, or slightly related to this. Can I have, or how do I create different versions of OpenShift to deploy into each one of those? Like, is it a set, like I can only deploy 4.13.1 or 4.12.17, or can I go in and create each one of those versions?
Yeah, that's what I was trying to ask earlier. I just did a really terrible job.
So I think what you're referring is you want to add more node pools, and you want to have different workers on different versions?
No, like a whole separate cluster. Like if I wanted to stand up a whole new hosted cluster that's using whatever version of OpenShift, I would assume that there's probably a limit or only a certain window of versions of OpenShift that I can deploy as a hosted control plane cluster. Yeah.
So I think you can probably, like with the self-managed, you can probably use whatever assisted has been taught to install. So
I think hosted control planes only supports clusters from a specific version.
Sure.
But yeah, you can use any Z stream or whatever you want.
Okay.
And Andrew, like if you wanted to do like an ARM with like a Hypershift or a hosted control plane, you change the release image. So like when you're doing your Hypershift, you're going through the Hypershift CLI, you just say use this release image, for like say the multi-arc, and then it'll go out and it'll deploy an ARM cluster as long as the cluster can, or the management cluster can support it.
Okay. Yeah, I think what you're showing there is what I was referring to, that OpenShift version. Is that something that, me as an administrator, can I control what versions show up there, or is that something that comes from MCE? Okay.
Yep.
So this comes from the agent cluster config, the agent service config. It's something, I think I can show it. So yeah, okay. I'm not going to create a new one. And I think if we go to here, I can show you exactly where this is coming from. So when we configure the assisted service, we tell it, okay, this is what you can install. These are the release images you are aware of. So I think they're here. Okay, so for 4.11 we have this release image, and for 4.12 we have this one, and 4.13 we have this one, and this is what you can see over there.
Okay, that's really cool. I didn't know that you could control that. So
I think this. I'm pretty sure this is what behind the scenes happens. Maybe I'm wrong here, but.
Alan asks if this works with Microshift.
So what's this like? Because what we showed
Microshift as a management cluster, no.
Yeah, I think so. I think the answer to that in all respects is going to be no. I don't know. Does ACM work with Microshift? I think it might.
No.
I don't think so. Not today, because Microshift isn't really OpenShift. It's the Kubernetes API, or just enough Kubernetes on the host to be able to deploy pods. None of the other, I think, things are
It's really
there.
for far edge use cases,
Yeah.
not hosting multiple other clusters.
Yeah.
Okay, I don't know if you noticed, but the host is back in the pool, and you can definitely reuse it for whatever other hosted cluster you want to create, or if you want to
Or
create
not hosted.
a regular cluster, works as well.
And also, this is one way. There's no such thing as single node OpenShift with this, right? Because your single node OpenShift is a single node that is both control plane and worker node. So you would be deploying the control plane, which is a highly available control plane, and then you could have one or more worker nodes. So it would be a single node in that respect, but it's not a combined cluster.
So wait,
Right.
I want to say maybe to make it more accurate. So you can definitely create a hosted control plane with one worker node. That's one thing. You can do that. We actually just did. But you can also use the same UI, go to central infrastructure management, use the same hosts that we just used as worker, and you can create your SNO, your single node OpenShift from here, and just get single node OpenShift. You can reuse the pool to do whatever you want. You can install OpenShift in whatever way.
I also wanted to point out, because I've been having a number of conversations about this as we're getting ready to update the subscription guide. If the cluster that's hosting the control plane workloads, if it's only hosting those workloads, they're infra workloads. So you don't need to entitle that cluster. You only need to entitle the compute nodes that are being added in to host whatever applications are being deployed. I thought that was particularly interesting with OpenShift virtualization as well. I have a physical cluster that I'm using with hosted control planes, and I'm deploying all of those virtual machines that are the worker nodes, the compute nodes for the hosted clusters. I only need to entitle those virtual compute nodes for those hosted clusters. Can this be done with AWS GovCloud? I don't know the answer to that. Yeah, I don't know the answer to that. I would assume so, but I don't know. That's a Jonny. That's a
our favorite hosted control plane PM is answering questions. So I guess he can answer that one too.
Now you outed Adele and what his role is and why he's answering questions. So
Good to have you, Adele.
Thank you for joining, Adele, and helping to answer questions. Again, kind of going back to being sensitive of time, especially for you all over there in Israel. If anybody has any questions, if there's anything that comes to mind, please don't hesitate to post that now while we're kind of closing out everything. Or, blew your cover. Or send it into email. Or send it in email or Slack or any of the other ways that you can reach out to us. So I will take a moment to thank everyone who has joined us today. Really appreciate all the chat, all the questions that you all have had. This has been really interesting to me. This is we've been watching this evolve over time and seeing it all come together here and seeing what that final experience, or close to the final experience, we're not at GA yet, but the close to final experience looks like. It's really, really cool to me. So thank you both for joining us. We really appreciate it, and we love having you engineering folks come and join us, because I always learn something, and especially with assisted installer and single node OpenShift, and again the CV that you all have, like it's been I've loved having you all correct me on things that I say.
Happy to be here.
So it's really fun.
Yeah.
But and then so thanks to our audience. Thank you to you two for joining us. Really appreciate it. Jonny, anything from your side?
Just looking forward to the next couple weeks, right? Thanks guys for coming on. It's really awesome. We appreciate your time. We know you're busy, and so thank you for coming here and enlightening us with all this, because this is it's really incredible what you guys have done. And your story is awesome too. The fact that you guys have known each other for a long time, and then you come over here together, I think that's awesome. So thanks for coming on, and Andrew, just looking forward to the next couple weeks, man. We got a full schedule. It's gonna be awesome.
I realized a moment ago that I might miss one or two of those due to traveling and stuff like that. I got to go to Denver in early August and all kinds of other stuff. So we'll see.
Man, getting fancy.
I don't know about that. Remember, Summit's in Denver next year. So.
Oh yeah.
But that's not why I'm going. I'm going to meet with a customer.
Oh, okay.
So, Eran, Avishay, anything from you all before we close out?
Nope, it was a pleasure.
Yeah.
Very much so.
Invite us again.
Yeah, you all are welcome anytime
that.
at all. Yeah, Johnny's kind of persistent when it comes to those things. He includes me on all the emails and all the messages that he sends out to guests. So. All right, y'all. Thanks a bunch. Really appreciate everybody's time today. Again, if you think of anything, if you're not watching us live, if you're watching the recording, don't hesitate to reach out. Andrew.Sullivan@redhat.com, Jonny, Jonny @redhat.com, or of course the Kubernetes Slack workspace. Look for the OpenShift users channel in there. And with that, we will see everyone next week. Still struggling with this new UI, Jonny.
They ruined it.
All right. Bye, y'all.